Hello everyone, welcome to lecture 5 for mathematics of grade 11. So in this video we are going to cover law of cosines. So if you remember, in the previous video we had law of sines. We saw a couple of examples for law of sines. But in this video we will see what is law of cosines and how we can apply it for some questions. So first of all, let's see what is law of cosines. For any triangle ABC, like this one here, with side lengths A, B, and C. So again, remember our convention. If the vertex is capital A, then the side opposite to that is shown by lowercase of the same letter. So if you have any triangle like this one, then we have these three relations in that triangle, which is called law of cosines. So for example, let's see the first relation. So choose side A, this side. If you square that side, A squared, that will be equal to the sum of the squares of the other two sides. So B squared plus C squared, and then you have to subtract this term from this sum. So minus 2BC times cosine of the angle between those two sides. So that's it. You can write this relation for any sides. The first one was written for A, so you can write it for B. So you can take this one, B squared is equal to A squared plus C squared minus 2AC cosine of the angle between them, which is B. Or you can write it for side C. So C squared equals B squared plus A squared minus 2AB cosine of the angle C. So that's called law of cosines in any triangle. Usually this law is applicable when we have when two side lengths are given and the angle between them is given, or sometimes when you have all the three side lengths, you can apply the law of cosines. Just one quick thing here before we go to the examples. Law of cosines that we have here is sort of generalization of Pythagorean theorem. So let's see what was Pythagorean. So Pythagorean was like this. So if you have a right triangle, which is right over here. So let's say this one is A, this one B, and this one C. So this one is little c, little b, and little a. So Pythagorean goes like this. You can say hypotenuse squared. So C squared equals A squared plus B squared. Okay? So that was this is Pythagorean theorem. But now let's write the law of cosines for this hypotenuse here. Let's write law of cosines. So according to law of cosines, we have C squared. So law of cosines. We have C squared equals A squared plus B squared minus 2 times A times B times cosine of the angle between them, which is the cosine of the angle C, but it is 90 degrees. So cosine of 90 degrees. But what is cosine of 90 degrees? It's 0. So this term is 0. Right? Cosine of 90 is 0. So 2AB times 0 is 0. So this term over here will vanish. So what remains is just this part, which is the same thing as Pythagorean theorem. So law of cosines is kind of generalization of Pythagorean theorem. All right. So let's see some examples. That first one says find the length of BC. BC is this one. We're going to find the length of BC. So look, two sides are given, and the angle, the included angle is given, right? So you should remember law of cosines here. Let's write the law of cosines for this side. So I'm going to call this side a, little a. So law of cosines becomes a squared equals, the other two sides is squared, so we have to add up the square of the other two sides. So 9 squared plus 14 squared minus 2 times 9 times 14 times cosine of the angle between them, which is cosine of angle A, which in this case is 62. So times cosine of 62 degrees. Well, now all we have to do here is to just do these operations and see what is the value of a squared, and at the end we can take a square root of that number. So let's see what is this sum over here. 9 squared, so a squared equals 9 squared is 81, and 14 squared is 196, minus 2 times 9 times 14 will be 252, and then times cosine of 62 degrees. So equals. So 81 plus 196 will be 277 minus. And now here you can use a calculator and multiply 252 by cosine of 62 degrees. So the answer is about 118.3. Okay. And this will be equal to 158.7. So a squared equals 158.7. Therefore, a is the square root of this number, which is about 12.6. So this is just an approximation of the real answer. 12.6 is the value of side BC in this case. All right. Now, next example says find measure of angle R. So angle R is this one over here. Again, 3 side lengths are given. So we have to use a law of cosines here because we have all 3 sides length, right? So let's write the law of cosines for this side over here, because this side will relate the relation to the opposite angle, which we want to find here in this case. Okay, so let's write the law of cosines. 9 squared equals 4 squared plus 7 squared minus 2 times 4 times 7 times cosine of angle R. So that's the relation that we have. That's the law of cosines. All right, so 9 squared is 81 equals 4 squared is 16 plus 49 minus 2 times 4 is 8. 8 times 7, 56 cosine of R. Okay, so 81 equals 16 plus 49 is 65 minus 56 cosine of R. So we will take 65 to other side. So 81 minus 65 will give us 16 equals negative 56 cosine of angle R. Now here we'll find cosine of angle R by dividing the left-hand side by negative 56, which is equal to minus 0.285. Now you know what to do, right? So to find the angle R, we have to use cosine inverse operation, right? So we'll take cosine inverse of this number over here. So angle R equals cosine inverse of negative 0.285 And now here you can use a calculator to get the answer, which is about 106.5 degrees. So that's the measure of angle R here, 106.5. And that's it for this video.